All right, this topic is on simplifying exponential expressions, okay? So now we've learned the basics. We've learned about how we learned about just simple exponents. 3 to the second power is 3 times 3, and that equals 9. We've learned about zero exponents, where any number that has a 0 for an exponent is 1, okay, no matter what. And then we've also learned that any number that has a 1 for an exponent equals itself, okay? Now, and we also learned negative exponents, where any number that has a negative attached to it, you have to flip it to the other side of the fraction bar, like that, or vice versa. Right. Okay. So it's converse, right? If there's no 1 under or over it, right, you put it underneath 1 and then solve as normal. If it's negative exponent and it's underneath 1, you flip it and then you get rid of the exponent and solve as normal. Okay. So now we need to what if we have them all together and we have an expression? Okay. So let's start off simple. Let's say we have 5x to the negative 4th. Okay, so let's start with that. Okay, so now we have now you have to split it up into different pieces. We have a number here, and then we have a letter to a negative exponent. Okay, so we look. Our 5 doesn't have an exponent. Okay, so it stays the way it is, but our x does. It has a negative 4. Okay. Now, we know about negative exponents, remember, and I can rewrite it over here. Like this. Okay. So now we know that if our x has a negative exponent, this exponent only goes to the x. It doesn't go to the 5, only the x, okay? So if we were to rewrite this, okay, our 5 stays where it is, but our x, because it's negative, has to go underneath a 1. Well, we have a 5 here, so we don't need a 1. We can just put it underneath the 5, and then the exponent stays the same, but it's now positive. Okay, and obviously you can't do anything with this because that doesn't have an x, doesn't have a base number, so it stays as 5 over x to the 4th. Okay, so all we did was just move our x, because it had a negative exponent, to the bottom of our expression here. Okay, that's all we're doing. Okay, let's try something else. Let's do 3 to the negative 2nd over x. Okay, so we look at our two terms here. Okay, we have a 3 with a negative exponent, and then we have our x just chilling by itself. Okay, so what do we need to move? Well, we see our x doesn't have an exponent, so it stays where it is, but our 3 does. As a negative 2, which means this, as we know, has to go underneath, has to flip and go underneath the fraction bar. So, and the 1 goes on top. Now, if we draw our fraction bar, okay, this goes underneath now. And exponent becomes positive, and our x stays where it is. Well, we need something to go on top, and that's where our placeholder over 1 goes on top. Now, when we get here, we solve, if we can. 3 squared, we know what 3 squared is. 3 squared is 9, and our x stays there. Okay. So, once again, my 3 has a negative exponent. I know that I need to flip it and put it underneath a fraction bar, so I did. The 1 has to go on top because there's nothing else on top. Our x has no exponent, so it stays where it is, underneath the fraction bar. And then I can go ahead and do 3 to the 2nd power, and that's 9. Our x is still there. Okay. Let's try c to the negative 5, d to the 7th. Okay. So we have a c and a d. We have negative 5 goes to our c, and 7 goes to the d. So let's look at our exponents. Our c is a negative exponent, so that we know that has to move. But our d does not, so it can stay where it is. So if we draw a fraction bar, okay, our c has a negative, it has to go underneath the fraction bar with the exponent coming with it, but now it's positive. Our d has a positive exponent, so it stays the way it stays where it is, okay? It stays on top. And because they're different letters, you can't do anything. It stays just like that. Okay, so the d doesn't move. It has a 7 positive. Our c has to move because it has a negative 5. It goes underneath the fraction bar. And we can't do anything from there because they're both different letters, so it just stays the way it is. Let's try one more. Well, let's try a few more. Let's do 5a 3 b negative 2. Okay, so we have three things going on here. We have our 5, we have our a to the third, and our b to the negative second. Okay, so look at the exponents. The 5 doesn't have one, it stays. The a has a 3, it's a positive exponent, it stays. Our b has a negative exponent, has to be flipped. So if we draw our fraction bar, okay, our 5 doesn't move, it stays. Our a to the 3 doesn't move, it stays. But our b has a negative exponent, has to go on the bottom, flipped, exponent stays as 2. And because they're all different terms, that's going to be our answer. Okay, we're just moving stuff around, guys. We're not making this complicated. We're not doing anything crazy here. Moving things around. Okay. Let's try one more. Let's do 8 over 2 x to the negative third. Okay, so look at what we have here. We have an 8 on top, and we have a 2 on the bottom, along with the x with a negative exponent. Now remember, our negative exponent only goes to the x, not the 2, only the x. So what do we have to move? Where our 8 doesn't have one, it stays where it is. Okay, so if we draw our fraction bar, our 8 stays. Our 2 down here has no exponent, it stays. Our x, though, has to go on top. And then our fraction bar, our negative goes away. Now, are we done? Not quite. Because what we can do, we have an 8 and a 2, we can simplify those things, right? The fraction bar means division, right? So go ahead and divide. If you can divide it, divide it. 8 divided by 2. And we know that 8 divided by 2 is 4, right? Our x stays where it is. Now, if you want, you can put it over 1 because that's how it is, but you don't have to. You can go ahead and just leave it as 4x to the third power. Okay, so if you can divide your numbers, once you get to this point here, if you can divide them, divide 8 divided by 4, or sorry, 8 divided by 2 is 4. And then your x is now on top, so it stays next to the 4 with it there, okay? So that's what there is to it. Make sure you have this written down somewhere so you know that's how it works out. You know that it's 0 power is 1. 1 power is itself. A negative exponent has to get flipped, vice versa. If it's by itself, it goes underneath 1. If it's underneath 1, it goes by itself. Okay. And that's pretty. And that's let's do. You want to do one more? Let's do one more. I just want to make sure you guys get this. Okay. 6a to the negative 1, c to the negative 3 over d to the 0. Okay, so let's look at all we have. Okay, break it up. We have a 6, we have an a to a negative 1, c to negative 3, and on the bottom we have a d to the 0. Okay, so let's go ahead and draw our fraction bar right now. Okay, first step, 6. No exponent at all, stays where it is. Our a is a negative 1. Negative means it has to go underneath the fraction bar, so we flip it. A to the 1, okay? Our c, negative exponent, same thing. Has to go underneath the fraction bar. C, exponent comes with it. Now, on the bottom, our d has an exponent of 0. Now remember, if it has an exponent of 0, it's 1. So our D becomes basically a 1, okay? So now we pretty much have our answer, right? 6 stays on top by itself. Our a to the first is just itself, right? A. Our C3 is like that, and our 1 here can just go away. And that's our final answer. 6 over a c to the third. Okay? Simple stuff, just moving things around, top and bottom. Okay, just remember negative exponents. Goes with it, nothing too complicated, all right? Just remember these basic terms here, and we'll be okay.